Welcome to another video. In this video, we'll be doing a maximization slash minimization problem. A rectangular area is to be fenced using 32 meters of wire. Find the length and width of the rectangle if it is to enclose the maximum area. Now, this follows from the previous video where we looked at max min. The idea is the same. So what we need to do is we need to differentiate and equate to 0. But what it is that we need to differentiate? So let's start by writing down what is given. Now we know we have a rectangular area, so let's do a sketch of that area. So we sketch this area. Let's call our length or width. Now we know that we are to use 32 meters of wire. That tells us that the perimeter of the rectangular area should be 32. So it means that taking the sum of all four sides, we have 2L plus 2W to be equal to 32, and we can write this as L plus W to be equal to 16. So we're dividing throughout by 2. Now what we want to do is we need to find the length and width of the rectangle if it is to enclose the maximum area. So what we're trying to do here is we want to maximize the area. Now, how do we find the area of a rectangle? Well, of this rectangle, it would be the length times the width. So since this is what we want to maximize, so we want to find a maximum area, which means that we want to maximize the area. So since this is what we want to maximize, this is what we need to differentiate. However, if you notice, it is in terms of two variables. Now we need to get it in terms of one. So what we're going to do is we're going to come back here and we're going to make one of these guys, L or W, we're going to make one of them the subject of the formula. So I can make L be equal to 16 minus W. So since L is equal to 16 minus W, I can replace this L here with 16 minus W. So the area is equal to 16 minus W. So that would be my L times W. So A is equal to 16W minus W squared. Now, following from before, we know we need to differentiate this and equate to 0. So we're going to differentiate A with respect to W. So what we'll have is dA by dW. So we're differentiating A with respect to W. And this is equal to, so differentiating this guy here, we have 16 minus differentiating W squared gives us 2W. Now at the maximum or minimum point, this derivative 16 minus 2W should be equal to 0. Now since when the derivative is equal to 0, we have the max or min, we equate 16 minus 2W to 0, and solving this here, we get 16 to be equal to 2W and W to be equal to 8. Now we can also find L. If you recall, W plus L was equal to 16. So we can replace W, substitute W as 8. So we have 8 plus L to be equal to 16. and this gives L to be equal to 8. So both the length and the width are 8. Now, how is it that we're sure that this is the maximum area and not the minimum? So we can find the second derivative. So d squared a by dw squared is equal to, so differentiating 16, that's 0. Differentiating minus 2w, that's minus 2. So the second derivative gives us a negative number that is less than 0, right? Which means that we have a maximum point. So therefore, we have a max area when the length is equal to the width, which is equal to 8. Now, oftentimes students ask, then isn't that a square? But just bear in mind that all squares are rectangles, but all rectangles are not squares.